Welcome to this comprehensive guide on building a robust game manager system in Unity, designed specifically for beginners in C# and Unity development. A game manager acts as a central control system, overseeing game states, managing player progress, and preventing redundant code, making it essential for organized game development. While ideal for simple games, more complex projects might benefit from advanced state machines. But for now, we'll focus on managing core states like start, pause, and game over. Let's begin by creating a new Unity project. Open Unity Hub and select New Project, choosing the 3D Core template for our foundation. Once the project loads, you'll see the basic Unity interface, the hierarchy window, scene view, game view, and inspector window, each serving a crucial role. Next, we'll set up the UI elements for our start, pause, and game over screens. This involves creating a canvas and adding buttons and text objects. The canvas is essential as it's the area where all UI elements are rendered, ensuring they scale correctly across different screen resolutions. Now, let's create our game manager script. In the project window, right-click, select Create, then C# script, and name it Game Manager. Open the Game Manager script in Visual Studio. We'll implement the singleton pattern, ensuring only one instance of our game manager exists throughout the game. This pattern is crucial for central control, preventing conflicts from multiple manager instances. A helpful tip: always initialize your singleton in the awake method. To persist our game manager across different scenes, we'll use don't destroy on load within the awake method. Next, define an enum called GameState to manage different game states. This will include intro, main_menu, game, pause, and game_over. We'll also create a public variable public game state, current game state, to track the active state. Now, let's create a method, setGameState, to update the current game state and trigger events based on these changes. This method will be the central point for all state transitions, allowing us to control UI visibility and game logic efficiently. Let's implement the start screen. Create a simple UI panel with a start game button and a title text. Attach a script to this start game button that calls our game manager. Instance.setGameState method when pressed. This transition will hide the start screen and activate the main game elements, moving from intro or main_menu to game. For the pause screen, we'll control game time using time.timescale. Setting it to 0 pauses the game, while 1 resumes normal speed. Create a pause button in your game UI. Link its on-click event to a function in your game manager that toggles time.timescale. To display UI elements only when paused, we can use tags. For example, tag your pause menu panel as pause menu and activate/deactivate it based on the game state. A useful tip: when animating pause menus, use unscaled time to ensure animations play smoothly even when time.timescale is 0. Finally, the game over screen. Create a panel with a game over text, a score display, and restart and main menu buttons. The restart button will reload the current scene using scenemanager.loadScene. The main menu button will load your designated main menu scene. For example, scenemanager.loadScene. Remember to add using UnityEngine.SceneManagement at the top of your script to access these functions. Now, let's integrate our game manager. To reference it in other scripts, simply use Game Manager instance. This allows any script to easily access and modify game states or other manager functionalities. A valuable tip for beginners: use Serialize field to expose private variables in the inspector. This allows you to tweak values directly in Unity without constantly modifying and recompiling your C# code. Understand the awake and start lifecycle functions for initialization. Awake is called when the script instance is being loaded before start. Start is called on the frame when a script is first enabled, just before any update methods are called the first time. For best practices, consider using scriptable objects to store game data like player stats or item definitions. This separates data from logic, making your game more modular and easier to manage. Avoid frequent use of GameObject, find as it can be a performance bottleneck, especially in larger projects. Instead, use references set in the inspector or find objects once and store their references. Implement object pooling for frequently instantiated objects like bullets or enemies to reduce instantiation overhead and improve performance. For time-based events, prefer coroutines over invoke repeating for more flexible and readable code. Finally, as your game grows, consider implementing a full state machine to manage complex game states more robustly than simple enums. You've now learned the fundamentals of creating a game manager system in Unity, from setting up UI to implementing core game states and best practices. Keep experimenting and building, and you'll master game development in no time. Thank you for watching.